Okay. We'll start off here. Okay. All right. Greetings, scholars. Let's see. So we are at the end of week. I totally was about to say we're at the end of week. So, sometimes I definitely switch the first letters of my words. It is what it is. But yeah, we're at the end of week 14. All right. So a brief synopsis of the remaining schedule, right? So today we're going to continue reviewing exam one. We're going to make our way through. We're going to redo exam one and take the actual exam, and I'll try to get answer as many questions as we can with the time allotted. And then we won't know if it's right until like the last 10 minutes of class or so. And then so next week we only meet on Monday, right? And so we'll use that day to review for exam two. We'll probably just retake exam two. We're going to be off that Wednesday, November 23rd. That's the Wednesday before Thanksgiving, which is a week from today. So we'll enjoy your holiday. Spend time with your loved ones. You want to maximize just the time you have with the people that you care about. So then we come back after the holiday. We meet on that Monday and Wednesday. That Wednesday, November 30th, is the official last day of class. December 1st and 2nd, that's the reading period. So you shouldn't be meeting in any of your courses. And then, so your final exam should become available Sunday, December 4th at 11:11 a.m. and it's due Friday, December 9th at 11:59 p.m. Let me see. There was something else I wanted to say. Okay, well, as we rapidly approach the hard deadline of Friday, December 9th, oh, that's what it was. So during the week of finals, more than likely I'll come online during our regular class time just to make myself available. You're not required to attend during the final. You just need to submit your final, right? The goal or the idea is that when you submit your final exam, you should be done with everything. If you are going back and redoing old assignments to improve your old score, I would encourage you to prioritize your exams as they count for 80% of your overall grade. So that's where you're going to get the most bang for your bucks. The last thing you want to prioritize is the old homework. That's going to be a whole lot of work for little to no points, right? You won't really see your grade shift or jump, going through the homework. That's going to be a whole bunch of work for, nominal points. So you want to prioritize your old exams. So after November 30th, that's our last official day of class. And again, I more than likely will come online on that Monday and Wednesday. I'm not promising this, but more than likely I'll be online that Monday and Wednesday during the week of finals during our regular class time, just so you can find me if you have questions. And you can ask me questions about anything that's on Pearson. If you work on your final and you're stuck on a question, you can ask me and we can work on it together. Unlimited attempts. There's no late penalty for the final because you can't submit that late. And then the usual late penalty holds for everything else. As always, if you have questions, feel free to unmute yourself. That's my recommendation. That's the fastest way to get a response. Or you can type in the chat. I do check the chat periodically. I check it periodically. Let me get these two students. We'll let them in. And so today, let's take some time and let's make our way through exam one. So let's try to get through as many questions as we can. And again, we won't really know. We won't know if we got them correct until we submit it. So, to minimize, our chances of getting it wrong, we should check our work and stuff like that. If a function f has an inverse and f of -9 is 4, then what's f inverse of 4, right? So the inverse of a function undoes the function. Say you start with x equals -9, you pass it through the function, and then the output is 4. When you take that output and pass it through the inverse, it takes you back to where you started from. So that output should be -9. Okay. go on to the next one. For f of x equal to this, find each of the following. Okay. Okay, so when x more than likely is negative 12, right? 2 to the power of 3 is 8, so that's going to be negative 8 minus 4 is indeed negative 12. So this one is going to be negative 12. This one is going to be negative 2. Right here, come on. Here, negative 2. And then f of f inverse is, they cancel each other out, so that should just be 463. All right. That open circle, remember that symbol in part C? That means composition of functions. That means the second function inside the first function. That's not multiplication. That means the second function inside the first function. And the whole point of a function with its composed inverse is that they cancel each other out. So it should just be 463. I'm gonna go on to the next question. Okay. Graph the inverse of the one-to-one function. Choose the correct graph. So it looks like f might be in blue. And then to get the graph of our inverse, we rotate about the line y equals x. Let me zoom out. Shyster. Oh, hope we didn't lose our work. Oh, we may have lost our work. Hopefully we didn't. I was trying to zoom in. And we may have just lost whatever work we did. Finish the test. Okay, looks like it saved that one. That one looks good as well. Just a moment. Okay. Let's see. So it wasn't that. So let's try this. Okay, that's better. I think if I click on something, it'll make it behave proper. Just got to click on the right thing. There it is. Nope. There it is. Okay. All right. So, so when you have a function, to get its inverse, you rotate about the diagonal y equals x. So the only graph that's rotated about the diagonal y equals x is going to be b. So, you know, they should be mirror images of each other about the diagonal y equals x. So that's going to be b. Let's go with b. I'll give it a couple more minutes. Let's go on to the next question. It says determine whether the function shown below is one-to-one. Okay, if it is, find the inverse. So if we think about this graph, right, this is going to be the square root function. We'll remove it left 4 and up 5. So then the square root function is going to pass the horizontal line test. So it is one-to-one. Let's do the algebra on this. Let's do the algebra on this. Get a copy of it. Okay. We're working there. Let me just work here. Copy and delete. What time is it? Then let me paste. Allow paste. Okay. All right. So algebraically, to show that a function is one-to-one, when we equate two different y values, we need to show that the two different x values are equal. If we equate two different y values and we finish with the x values being different or not equal, then it's not 1-to-1, right? Okay. So, we need to start with f of a equal to f of b. And then if we finish with a equals b, then it's 1-to-1. If we finish with a is not equal to b, then it's not 1-to-1. All right. So then we're going to have 5 plus the square root of a, that's going to be a b actually, b plus 4. And then basically it's the same thing on the other side. Let's just copy and paste. But instead of b, it's a. Okay. We said if we started with f of a equals f of b. Notice we can subtract 5 on both sides. We'll get the square root of a plus 4 equals the square root of b plus 4. You can square both sides, so still no need for a plus or minus. So then you'll have a plus 4 equals b plus 4. And then subtract 4 on both sides, you get a equals b. Right? And let me show the highlights. So, first thing we did, we subtracted, we basically added -5 on both sides or subtracted 5 on both sides. It's the same thing, right? Then we squared both sides. Okay. Then we subtracted 4 from both sides. And we finished with a equals b. So that's how we show a function is 1-to-1. Okay. So then we've shown it at least 2 different ways. We described the graph. The graph passes the horizontal line test. Also, we show it algebraically. So is the graph 1-to-1? We're going to say yes, if my device to stop being so trippy. Now, let's go back and identify our domain and range. So the domain of this guy, the only restriction is we cannot take the square root of a negative, right? So that x plus 4 has to be greater than or equal to 0, okay? So for the domain, x plus 4 has to be greater than or equal to 0. So then x is greater than or equal to -4, okay? That's the domain of f. And then the range of f, normally it would be from 0 to infinity, but we moved it up by 5. So it's going to go from 5 to infinity, 5 to infinity. And you want to include the 5. You want to go from -4 to infinity. Infinity always gets a parentheses, -4 gets a bracket, okay? So we have the domain and the range of f. And this is important because once you identify the domain and range of f, then the domain and range of f inverse become easy. It's basically the reverse, right? You flip the two. Flip the two outcomes. So the inverse, let's go ahead and find the inverse. Okay. So if that's the domain of f, then this is the range of f inverse. And this is the domain of f inverse. Okay. And then if we're starting with, let me get a copy. I guess I can just take this. This will be enough. Let's copy. Now it'll work here. Let's paste. Oh, it took all that. That sucks. All right. Well, if it's going to do that, then let me see something. I can go like this. Yeah. Delete that. All right, we want this. We want this. We want this. This can go. And we got to change it from a. So I'm just getting a copy of the original. Okay. Now to find the inverse, and here, let's go ahead and label this. So to find the inverse, first thing we do is replace f of x with y. Next, we switch all x's and y's. So all x's and y's switch places. So then we get x equals 5 plus y plus 4. Then we solve for y, okay? So then we're gonna have x minus 5, square root of y plus 4. We square both sides, okay? I'm going to rewrite it like this. So then we're going to get y plus 4 equals, I'm going to leave it as x minus 5 quantity squared. I'm going to leave it like that. And then subtract 4 on both sides. So then y equals x minus 5 squared minus 4. So then now you just replace y with f inverse. X minus 5 squared minus 4. And the range of f is the domain of f inverse. So this domain goes from 5 to infinity. Okay. All right, so this is basically the right-hand side of a parabola. Okay. I think we have enough information to answer the question. Okay. So what is the inverse? Let's see. We got x minus 5 squared minus 4, x minus 5 squared minus 4. So then it has to be either A or B. And I think we said the domain of f inverse was x was greater than or equal to 5. Let me just check one more time. Greater than or equal to 5. Okay. So let's go with C. Okay. So it looks like f is in red. Remember, we said that's the top half of that's a square root function. We moved it left 4 and up 5. Okay. So it looks like it has to be either A, B, or C, because D, F is in the wrong position. Okay. It can't be B. B isn't proper. And then basically it's whichever one has been rotated about the diagonal y equals x, it should be A. Because B is improper, it completely ignored the domain of f inverse. C was rotated about the wrong axes, and then F, everything is backwards. I mean, D, everything is backwards. So we're going to go with A there. The domain that intercepts. The domain of F we said went from -4 to infinity, and the range, yeah, I'm thinking B, right? -4 to infinity, and then 5 to infinity. Okay. Because the domain of f is the range. Sorry, yeah, the domain of f is the range of f inverse, and the range of f is the domain of f inverse, right? So this is really domain and range of f. It's just instead of calling it the range of f, they called it domain, the domain of f inverse. Okay, hopefully that wasn't too circular. What are the intercepts of the one-to-one function and its inverse? So if we went left 4 and up 5, there's no x-intercept, but the y-intercept, if you set x to 0, is 7, right? And we can look at the graph to confirm. Yeah, it's 7, right? So for f, there is no x-intercept, but the y-intercept is 7. And then for f inverse, it's reverse. The x-intercept is 7, but there's no, so let's go with B. Okay. Okay. Find the inverse of the function shown below. Okay, and x is greater than or equal to 0. So what this is a V-shaped graph that we move down by 1. And we're only taking the right-hand side of it, right? Because x is greater than or equal to 0, we're only taking the right-hand side. X plus 1, right? So let me see, if that domain goes from 0 to infinity, if we only moved it down by 1, then that means the range goes from -1 to infinity. So now that means the domain of f inverse should go from -1 to infinity. So it should be either A or D. And I think D is correct. I'm going to go with D. Okay. So then F should be a diagonal if you rotate about the line y equals x. Yeah, it's the same diagonal. So F is in red. Yeah, I think it's A is looking promising. The problem with C is it ignores the domain. B, I think B has it backwards. Right, it has F and X backwards, and then D is just off. So let's go with A. And let's go into the next question. All right, let me check on you guys in Zoom. Let me get this student. Oh, ho, ho. Okay, the chat looks clear. Okay. So it says if a waiter works for $135 a week plus 10% commission on total dining tabs, his weekly salary is this, where Y represents the salary and X represents the total dining tabs. Find the inverse function and use it to find the total dining tabs for a week in which the waiter's salary was this. Okay. So find the inverse. So the inverse, you switch the X and the Y and solve. You're going to get X minus 135 all divided by 0.1. Okay. So here, we're going to have, let's do a fraction, X minus 135 divided by 0.1. So dividing by 0.1, that's what, 1 over 10? That's the same as, you can just multiply by 10. So then that'll be 10x there, and that'll be 1350. 10x minus 1350, 10x minus 1350, okay? Find the inverse and use it to find the tabs in which the waiter's salary, he earned $903.10 that week. So then if we want the total dining tabs, we put this in the inverse and it'll take us back to the start. Hey Siri, what's 10 times 903.1 minus 1350?
10 times 903.1 minus 1,350 is 7,681.
Okay, we obviously did something wrong. So we need to go back and let me see. X, okay, I think I see it. If we say X minus 135, no. That's what? Multiplied by 10. Okay, maybe. Let's see, if a waiter works for 135 per week plus 10% commissions and tabs, 7,000? 1,000 a night? That seems excessive. Something doesn't seem right there. Okay, I'm gonna redo it just because I'm not confident in that answer. I mean, I guess it could be the case. It just seems, oh, the total dining tabs, not the total number of tables. Dining tabs. Okay, $7,000 for the week. Yeah, that could happen actually. I was thinking the number of tables. Okay. Hey Siri, what's 10 times 903.1 minus 1350?
10 times 903.1 minus 1,350 is 7,681.
So that's how much money the restaurant earned during the week. Okay, yeah, that's reasonable. I was misinterpreting. I'm gonna go with that. Hey Siri, repeat that answer.
10 times 903.1 minus 1,350 is 7,681.
Okay, I'm gonna go with this. All right. Let's see. So we'll see how we did momentarily. I'll check it. We're gonna go for anywhere for another 5 to 10 minutes. Use the graph of the rational function. Let me see. Use the graph of the rational function to complete the following statement. As x approaches -1 from the right. So -1 is there coming from the right. Y tends to negative infinity. Negative infinity. Okay, let's go on to the next one. What are the vertical asymptotes of the graph? X is -3 and 3. Type an equation. So, okay. We're going to say x equals -3, comma, x equals 3. I think that's fine. Find the vertical asymptotes of any of the graph. Okay. So the vertical asymptotes are going to occur at the x's that make the denominator 0, but there's a couple of, well, we're not going to find the x that makes the denominator 0, because if you focus on the denominator, what it is a U-shaped graph that's been shifted up by 5 units. In other words, it never crosses the x-axis. So it won't ever be 0. So then, there are no vertical asymptotes. Okay. All right, so this one, the vertical asymptotes are going to occur at the x's that make the denominator 0 while keeping the numerator non-zero, right? So then that's just going to be x equals 5. You type an equation, x equals 5. Because 5 makes the denominator 0. The horizontal asymptote, so for horizontal asymptotes, there's we have to do a test that has 3 different outcomes. We got to compare the degree of the numerator to the degree of the denominator. And this is like case, I think this is like case number, I guess it would be 2, but it's where the degree of the numerator is equal to the degree of the denominator. So we take the ratio of the leading coefficient. So in this case, the horizontal asymptote is going to occur at y equals 1/1, which is just y equals 1, right? So if I'm saying something and it's not like clear, you definitely want to go back to one of these 3 sections. It's either 1, 7, 2, 5, or 3, 1, and make sure you might want to review the discussion on asymptotes. Should be y equals 1. The ratio, in this case, it's the ratio of the leading coefficients because the degree of the numerator is equal to the degree of the denominator. The graph has one x-intercept. Let's do the y-intercept first. The y-intercept, if you set x to 0, we're going to get -4/5. So -4/5. Okay, like this. -4/5. Okay, so 5. Oh, right. Okay. The x-intercept is where we set y to 0, but a fraction is only 0 when the numerator is 0. So in other words, we set the numerator equal to 0 and solve, and we're going to get -4. -4. Okay. All right. So we said vertical asymptote is x equals 5. Okay. So it's either A or C. Horizontal asymptote, we said, was y equals 1. Okay, so I think C has the wrong horizontal asymptote. So then with those 2 pieces of information, we can be confident in A. Okay. All right, let's do a couple more, one or two more. Then we're gonna cross our fingers and see how do we do. Use the 7-step method described in the book to graph. Okay, determine the symmetry of the function. Okay. So for instance, if we wanted to do a test for x-axis symmetry, we would change y to negative y and simplify. If we get back to the original, then we'd have x-axis symmetry. For y-axis symmetry, we change x to negative x and simplify. If we get back to the original, then we have y-axis symmetry. I am going to do it a little bit different, and I'm going to do a test for even or odd. If the function turns out to be even, that means y-axis symmetry. If the function turns out to be odd, that means origin symmetry, right? Yeah, I'm just gonna, so if I replace x with negative x, we do indeed get back to the original. So that means the function is even. Sorry. Yeah, that's fine. All right. So this function is even, which means that it has y-axis symmetry. All right. One other thing I wanted to mention, for odd, when you replace x with negative x, if you get negative times the original, then that means the function is odd. Okay. The y-intercept, you set x to 0 and solve, and it looks like you get 0, which is the origin. So I'm just going to put 0. X-intercept, if you set y to 0, which in this case would be the numerator, you're going to get the same result. 0. Okay. The vertical asymptote is going to be any x that makes the denominator 0. In this case, it's going to be plus or minus 1. So we're going to put -1 and +1. I think I'm going to go ahead and make this the last one. Horizontal. So we need to compare the degree of the numerator to the degree of the denominator. In this case, the degree of the numerator is equal to the degree of the denominator. So we take the ratio of the leading coefficients. In other words, in this case, the horizontal asymptote is going to occur at y equals 2. Okay, so you might want to, I would encourage you to just go back and glance and review that test for horizontal asymptotes, right? So it wouldn't hurt to look at that. Plot a few points. When x is -4, I'm tempted, let me see, type an integer or a simplified fraction. I think I'm gonna just use my calculator for this one. See if it's available. Yeah. So for this, I'm just gonna go to my y equals, trying to wrap this up, trying to get you guys out of here. So let's put the top in parentheses. We have 2x squared divided by the bottom in parentheses, x squared minus 1. Nope, minus 1. Okay, back to my home screen, and I just want to call on that function I just typed in. So when x is -4, let's hit math as a fraction. All right, we get 32/15. Let's just leave it as 32/15. This one. This is a long question. 32/15. Okay. When x is -3, -3 math as a fraction, 9/4. So I'm just going to go with 9/4. And this is a really long question. 9/4. -1/2. I get the output of -2/3. Come on. -2/3. Let me see if we can just go ahead and do 3 and 4. So here's 3. Ouch. And here's 4. So we got, oh, it's a repeat. Okay. So then 9/4, and then 32/15. Come on, 32/15. Okay. Okay, let's put all this together. So we said we had y-axis symmetry. It passes through the origin. Vertical asymptotes were plus or minus 1. Okay, I think it could still be any of these. Y = 2 was our horizontal. So it can't be A. So it's either A or C. So then the distinction, let's see, where's the origin? Oh, okay, wait a minute. I think B has the vertical asymptotes in the wrong location, and it's not passing through the origin. So the only one that fits those criteria is C. All right, we're just gonna hit next. And we answered half, so we might get close to 50%. I'm just gonna submit the test and see how do we do. That's fine, because we gotta go. Okay, it looks good. It looks like every question that we answered, we got correct. Yay! All right, guys. Are there any questions? I feel like there should be questions, but I get it. So if you can't ask me, hopefully you have like a trusted individual where you can, ask your questions and not be in the dark, okay? And get what you need. All right. Hop over here. So I'm for you guys send the box so that you can reference it. Phone. Come on. This one. This one. Notes. Updated. Blah, blah, blah. Right there. Okay. So when this bar finishes loading, you'll get a copy of anything that you saw me writing. And if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day. I'll see you again Monday next week. Same time, same place, guys. Take care. Peace. All right, so look, we had some people that came mega late. Go ahead and give them credit. I just barely caught them. I almost like exited out, then I would not have caught them, but. Hey, if you're just joining us, I'm just letting you know I went on to give you a tennis credit. I'm just letting you know that I saw you. All right, guys. I'll see you next week, same time, same place.